that really ends our conversation about shape from shading. I'll say that, as I said, lightness, it's still a pretty undersolved problem. Back in the 70s and 80s, where the view that the primary job of vision, or one of the primary jobs of vision, was to reconstruct geometry, there was a lot of focus on how geometry reflected itself in lightness and to try to undo that process. Remember, I talked about vision as being sort of inverse graphics. That whole focus has diminished quite a bit. And the other thing is the idea of being able to take derivatives in images with our current imaging systems, where things are very, all sorts of noise and kinds of things like that. It just was yielding very brittle kinds of results. And likewise, the types of assumptions we had to make were sort of overly restrictive. So I don't think my colleagues would disagree. It says we basically can't do that right now. Okay, so you show us a nice, my coat lying over there. You guys can't see it, the chair, etc., whatever. I can tell a lot of shading information by integrating many multiple cues. And we don't really have good techniques for doing that. There is a question of whether machine learning is actually at play. That is, maybe our system doesn't actually undo the physics of the image formation, but instead it has learned the relationship between certain image patch appearance and shape, and it just does that recognition or that mapping without undoing the physics. I would say the jury is still out on that, and probably the truth is going to be somewhere in between. I mean, Ted Adelson's demonstrations of that shadow casting, clearly there's a global effect on sort of a local process, and exactly how we do that is still unknown. So shape from shading is a very old problem, but we could probably use some very new solutions. But now at least you have some idea of the sort of the nature of the problem and what we have done.